Okay, it's loading. And then I'm gonna.
Oh, live on YouTube. Look at this. On the interwebs. How about that? Who would have thunk, you know, growing up,
Okay.
getting on the interwebs.
Okay.
If you write anything on your...
Good.
Oh, goodness. All right, Michelle, you want to kick us off here?
Let's get started. So we're live. We've got Jack and we've got June, and this is the third edition of the chain reaction around IBC. So basically today, I'm going to start looking at questions if you have them. Jack's going to run us through the demo that was launched right before the hackathon that we had this past weekend. And then June and Jack are going to answer questions and give their thoughts, feedback, and impressions. So I will hand it over to you, Jack, to
awesome.
get started.
Michelle, just real quick, when do we get intro music for chain reaction? I feel like this is, it's an opportunity, maybe for the next one.
But also we need to vote on what that music would be, right? Like rock.
Oh yeah, of course. You know, I think with chain reaction, there's like a lot of 50s era atomic stuff that I feel like we could make work. Anyway, yeah, chain reaction, anyway, kind of stupid. But all right, well, thank you everybody for joining us this morning. So I'm gonna walk through the IBC demo that we have. If you'd like to do this demo, and we'll post links to this in the comments for YouTube, but there's a pull request on the Gaia repo, and that's github.com/cosmos/Gaia, pull 172. If you look in the pull request, you should be able to pretty quickly find it. And in there's a README that helps you run a demo that shows you how IBC functionally works. Like as a developer, if I want to transfer assets between two chains, how do I do it? And that's what we're going to run through here today. Now, there's also a script that you can run as well. It's entirely automated, and you basically have to input password a couple times, and it will run this whole thing as well. I'm going to run through it manually. So one of the first things that you're going to need to do is pull down the Gaia repo and check out this branch. This branch is actually incorrect. I will fix it. The branch that we're going to need is Federico Kuhn's IBC, Fedi Kuhn's IBC branch. And then you got to install Gaia. Once you've done that, you're ready to start creating two chains that you're then going to send assets between. Now, Gaia D and Gaia CLI have a bunch of utilities in them to allow you to easily stub out directories for these things. And we're going to use that to do this here. So I'm going to be referring to the one in my text editor while I do this. So the first thing that we need to do is create the, oh, no, wrong window here, is create the first chain. So that's chain IBC0. And if we look at the file tree that's created, you can see that this is all the necessary configuration files for that IBC0 node. We're going to do the same for IBC1. So in this demo, we're going to be sending tokens from IBC0 to IBC1. All right. Now there's some configuration that we need to do, some minor changes to the configuration files. And you can look at those in details, but this is basically changing the ports to allow us to run two nodes on different chains on the same machine. All right, and then one last little bit of housekeeping here. Just for clarity and ease of use, we're going to make the keys, the funds keys on both of the chains the exact same. So it's pretty clear which accounts we're sending and receiving from. And if you'll notice here, we have the addresses for both of those keys the same. So what have we done before I start up these Gaia? Well, I'll start up the Gaia D instances. But while we're doing that, what we've done so far, just to recap, is create two individual chains, each with their unique Genesis files, and start them up. And if we take a peek at the logs, we should see the blocks getting created. All right, now it's time to start building the basis blocks for IBC. Now, the core abstraction that all of the rest of them are kind of based on is this idea of a client. Now, a client allows one chain to track the like client from another chain. So we need to embed a root of trust from chain 1 into chain 0 and vice versa. So these two client commands here will help you do that. So we're going to create the client for IBC1 on IBC0, and that transaction returns successfully, as well as the opposite, and that transaction also returns successfully. So, and then here are the query commands for the clients, so we can see the data about it. Now, what is that root of trust? That root of trust is essentially a block header where we can see what the validator setups are and how they've changed. And this is the baseline security. This is where a lot of the baseline security that IBC as a protocol provides comes from. So these clients will need to be periodically updated, and we will see the clients be updated a number of times throughout this demo. All right, so once we have clients, the next abstraction that we need to create on that before we can send tokens is a connection. So a connection is a basic handshake between the two chains that allows for the creation of channels and the sending of application packets over top of that. A client can be associated with multiple connections as well. So that's kind of interesting. All right, now we have this giant handshake command here that we're going to be running through for the next minute or two. First thing you need to do is enter both passwords. Now I will note, this command is creating transactions on both IBC0 and IBC1. So first thing we do is there's a connection open init on IBC0. Then we're updating the client for IBC0 on IBC1. And there's 4 different pieces of this connection handshake with open clients interleaved between them. If you want to see the details on this, June, where in the specifications? This is ICS 3.
Yes, this is specified in the ICS 3 about the connection semantics. So, yep.
Cool. So if you want to see more details there, go into ICS 3 and you can see exactly how this connection handshake works. Now, all right, we are close to complete there. And then these are the transaction IDs, and you can actually use Gaia CLI here to query those transaction IDs individually on each chain and see more details about the transactions. I've also added to the output which clients and which connections are associated, i.e. what are the important arguments to each of these transactions, and tried to show you how the handshake works between the chains. You know, for me, I think that this is way more helpful than looking at kind of a connection diagram in a spec. Like if you're going to look at IBC3, looking and seeing it happen live really kind of helps solidify this. So hopefully that helps for you as well. All right, so these connections we will be able to query. That's awesome. So on IBC0, there's the connection end for the connection over on IBC1. And also on IBC1, vice versa. So all of this stuff is kind of mirror images of each other, and it can get kind of easy to get lost in the which one's on which chain and which one's on the other, but we've tried to make it fairly clear here. Now, the next thing we need to do once we have a connection is create a channel. This is another handshake, but the channel is an abstraction that has the format of what data is supposed to be traveling over top of it embedded within the connection, the handshake, channel, I'm sorry. So each channel, each connection can have multiple channels, but each channel is specific to an individual application protocol. So, all right, let's go ahead and create the connection here. And this is going to look really familiar. Instead of connection, it just says channel, and there's an open init, open try. June, what are the 4 different open transaction commands? I'm blanking on the top of my head. Open try, we'll see here in just a second.
ACK and confirm.
ACK and confirm, absolutely,
Yes.
with update clients in between there. So just to read this output here, this is the chain the transaction is being created on, this is the type of transaction, and this is data about the individual transaction. Boom.
We need to update client in between the handshake commands because it submits the new header that can be proven the previous state of the chain. So if we don't put the update client between each of the handshake process, the other chain cannot prove that the other chain is now processed the previous step of the handshake process.
That's a great point, Jude, and that is the reason for that. Now, in this demo, they're each sent as individual transactions. There's a lot of optimizations and automation that can be applied to this channel creation process. And the reason we've done it this way in the demo is to make it very clear so developers understand the mechanics of the protocol and how this is working. This concept here is basically a relayer. It's something that sits between the two chains and either does manual or automated transactions on behalf of users on both of the chains that are required for any individual interaction. And relayer software will improve. We have quite a bit of work to do on that area. But all right, so here is, once the channel's created, we can query it. So we're going to query the end of the channel. And here's the data here. You can see these proofs. These are the proofs that the handshake has been created correctly. And, June, do you want to talk a little bit about these different proof types and what these proofs are?
Sure. The proof types are defined under the ICS 23 commitment schemes. So the commitment means that a specific state of a chain can be proven outside of the chain using the commitment root. The identifier for the entire set of the state. So this IAVR-V and multi-store, two proof operations, provides that how this commitment scheme can be proven. So IAVL represent the IAVR store that the Tendermint and Cosmos SDK uses, which is the default Merkle tree implementation. And the multi-store is much more simpler but static and faster Merkle tree implementation that we use as the second layer on the IAVR tree. So these two Merkle proofs are concatenated inside the list and then passed into the other chain to prove the specific state inside a state, more specifically a key value pair.
Nice. Thank you, June. And this is for channel creation as well as sending. Now, when we query the channels, we have an open channel, which is very cool. There's different stages for each of the different stages of the handshake. Open means that we can send data on it. Now, port ID here is very important. This is the specific type of application protocol that we will be sending over this IBC channel. And in this case, it's bank. So we're sending essentially tokens from one chain to the other. And then we also have the channel ID here, as well as the proofs. All right. So now we're ready to move on to sending some tokens. We're just going to send one state from IBC0 to IBC1. And I'll do it a couple times so that we can see it and sort of talk through this flow here, because there is some complexity here. All right, this is the transaction IBC transfer command. And there's we're using the bank channel on channel 0. And then this is the account that we're using. Right. Okay, now one thing to note in this output here is the height. There's going to be a timeout on receive packet, and we're going to need to use this height variable here. Now, to receive the packet, let's first look on the receiving chain and see what the balance of this receiving account is. All we have is in token and stake. All right, now we're going to receive the packets. And you'll see this timeout here. The height that we had was 107. So we're going to add this timeout, add 1,000 to that timeout. And then we're going to receive on the receiving chain. Oop, there we go. 1, 2, 3, 4, 5, 6, 7, 8. And we do want to broadcast that. Oh, goodness. So there's an update client here as well to ensure that there hasn't been any malicious behavior on the other chain, and we're going to receive it. Okay, so now we will see in that account, the same account from earlier, we have one bank channel 1 stake token. And this is the token transfer between one chain and the other. Now, just to show you again here, we're going to transfer. This is a transaction on IBC0. And this is putting the message in the channel. And then we're going to receive. Note when you're receiving, you're going to need to increment the packet sequence. That timeout should still be fine. We've got plenty of blocks left there. And when we query the account and note this is on IBC1, we're going to see 2 of those bank 1 stakes. Awesome. So IBC is coming along. This is a complete demo of basically how the flow is going to work for developers. And we're maintaining a working demo of this type in order for developers to be able to begin to build application protocols and other applications on top of IBC. Note, this is still alpha software. The implementation is not fully spec complete. We are working towards that over the next month or so, but we've made excellent progress and are able to regularly send tokens between chains, and we will be starting testnets here sometime in the next couple of weeks as well. All right, I'm gonna go ahead and stop the share there and kick it off for questions.
So it looks like we have just one question from Mayor. Who pays for the, I think he references to the transaction fees. Who pays for the transaction fees for a pairwise connection? That's kind of the first question. And then I think the first user that wants to send a transaction between the pair of chains. Does that make sense in terms of a question? Or do we need more context?
Michelle, you're breaking up just a tad.
Ah.
You're breaking up just a tad. Can you repeat that? I'm sorry.
Yep. Who pays for the transaction fees for a pairwise connection?
So one thing to note here is that this is the entire transaction flow for setting up clients, connections, and channels. As a user, the only transactions you're going to need to worry about are the send and receive packet. Now, folks who are interested in sending data between these two chains will create and maintain those connections and channels. And we anticipate that to be the validators who are associated with those chains. The official role in the IBC protocol is called a relayer. So whoever is performing this relayer function will pay the transaction fees for the creation and maintenance of the channels. Now, as a user, you will likely pay transaction fees for sending and receiving tokens on chains. Does that make sense? In June, is that right?
That is right. And the connections are mostly persistence, and it does not need to be like updated every time that the packet has been sent, as you said. So it is relatively cheaper in the whole IBC connection process. That means that a validator or any person who has a economic relationship with the chain can open the connection simply.
Yeah. Awesome. Thank you, Michelle.
Yeah, I'm just checking if we gave him the answers that he needed. Then we have our own Chris Goes.
So, hi, Chris.
What security assumptions are made? And if one is to use IBC, who do I have to trust?
Jim, do you want to take that one?
Sure. The security assumptions are based on the validator's behavior and the relayer's behavior. So IBC rely upon the validator's secure state transition. So in the BFD case, if the supermajority of the validator set, say 2/3 of the validator sets are malicious, they can modify the state maliciously and submit that. But if that's under 2/3, we can submit the misbehavior proof when they equivocate a specific header. So first, IBC is dependent on the less than 2/3 of the Byzantine behaviors, and it is dependent on the least one relayers. The liveness dependent on the least one relayer, and the safeness does not dependent on any relayers. So any malicious behavior cannot submit an invalid message. That's protected by the IBC. And if there's any single relayer that is honest, IBC connection or relayer will work fully.
Awesome. Chris, hopefully that answers your question.
He also says hi, Jack.
Oh, thank you.
So I guess then we don't really have so many more questions, but I have I'll wait to see if some other people are joining, watching now, have some questions. But in terms of the relayer, bear with me because I'm a bit of a layman.
Yeah.
On this. But is that?
Well, I think any questions are good questions, especially on stuff like this, because it's going to take a lot of different ways to explain this for different people to understand it. So please ask away.
I think I'm just impressed that we can transfer between chains tokens.
Yeah.
Just how long have we been on here? 20 minutes, your 20-minute demo?
Yeah, I think, I ran through it alone and it takes about 7 minutes if you're not explaining anything. It is relatively quick. And I think one of the coolest pieces of this process is that the longest pieces of it, which are the handshake commands, basically get reused. And I think, Michelle, you were asking about the concept of a relayer and what is that? Now, obviously, if you think about the concept of a chain can't like reach out and make HTTP requests. It doesn't know where other chains are. There's no way for the chain to, from the state machine, make an HTTP request. What would that look like? Each of the validators would each be making a request. Like, that's kind of messy. So there's some sort of actor that needs to be able to make the requests required for these connection handshakes and for the sending and receiving of tokens. This actor needs to know where the two chains are and how to send HTTP requests to them. And that's pretty much about it. But that role is a relayer. Now, what does the current relayer look like? As you can see, we've kind of hacked it into Gaia CLI, and it creates and automatically reaches out to these two chains, introspects into the state, and is able to send data between them. Now, I think if we look further out on the roadmap, at IBC 1.0, I think we're going to break a lot of these commands out of the Gaia CLI binary, and we're going to move them into a separate relayer binary, so that it's much more differentiated. And then also we're going to work very hard on the user experience on these connection and handshake commands. As you can see right now, it's a little bit rough and very hard to automate. I think eventually there's going to be two predominant types of relayers. One type of relayer will be server side. It will be able to keep track of a large number of chains. It will be constantly sending automated transactions to and from those chains, clearing queues and doing sort of automated work on the behalf of someone like a validator who works on one of those chains and is transferring data back and forth and needs to maintain this kind of connection. That's more heavyweight. That's going to have a lot of features like whitelisting and blacklisting, and going to be mainly targeted at infrastructure users. Now, another type of relayer is very easy to imagine, is a JavaScript relayer, one that lives in the browser, and you give it roots of trust for each of the chains that you want to transact between. And that will seamlessly handle the transfer for you with a nice user experience that users expect out of something like a MetaMask. So thinking of more of this like industrial relayer use case where there's high volumes of data sending between chains, and then more of a user use case where I'm a user and I want to send data over to a decentralized exchange to trade it, or I want to bring in some assets for Ethereum and use them in a decentralized finance protocol. Like that's the JavaScript relayer. So, that's my thoughts on how the relayers evolve. June, do you have any thoughts on that? Am I off base there?
The relayers currently is not directly incentivized, nor by the protocol or by any external protocol. There need to be a relayer incentivization protocol in the future if we want to make it truly decentralized. For now, only two main party, as you said, has the incentive to run the relayer, the either validator or like directly party that directly associated with the chain, or the user themselves. Yeah. So it will be better if we design the nice incentive protocol that makes any party purely run by the economic rationality can run, relayer, and send any packet regardless of their.
So,
one thing that I will note about that, June, is that current relayer cost, operational cost, is very low relatively. So we're expecting this cost to be borne by validators and other folks with a self-interest in facilitating transfers between these chains. Making the relayer a incentivized piece of the protocol is kind of a version 2 type of idea, but definitely something that we've discussed quite a bit. There's a lot of complexity around fees and how that would happen with the IBC packets. It's very, very difficult to work through, especially without understanding access patterns and usage patterns in a protocol like this. So I think one of the reasons why we left that until a future iteration of the design is because of that complexity, and because we do expect validators to bear these economic costs in the short run.
Definitely. And either the decentralized relayer design will be only efficient when there is more than like 1,000 of the chains connected to each other.
Exactly. So we need to build this ecosystem out quite a bit before we get there.
So does that mean that people eventually will be able to pick the relayer that fits them?
Yeah.
Okay.
In the same way that you would pick the validator that fits you. You know, it's
what you want to use.
It's a very programmatic interaction. And it requires somebody to just keep some data secure and keep a signing key hot. So there is a little bit of operational risk there. I think it's pretty easy to mitigate. But yeah.
So basically, we also need a lot more data before we can come up with maybe the relayer that makes sense to economically incentivize people.
Yeah, exactly. And like, as we're talking about, we're theorizing what these different pieces of different ways that you could construct a relayer and different use cases for it. And like, I'm fairly certain those are going to be 2 large use cases, but until we see this deployed and until we see this actually working, I don't think we're going to know. And that's another thing about IBC is this is a first of its kind protocol. Like, we've never really been able to have this sort of like trustless database to database interaction. And I think the closest analogy that we've seen to it is the internet, the ability for these computers to trustlessly send data between each other over something like TLS. And if you've ever studied TLS handshakes or the TCP/IP protocol, IBC is architected in the exact same way. It's a layered connection protocol is what this class of protocol is called. And I think we're only going to know more about how to incentivize the different pieces of this once we see network usage. And that's kind of what we're trying to kickstart today.
Okay. And just like the last point on that, and then I think there's another question. In time-wise, is that like a 2-month time frame or a year time frame when we can come back and talk about this?
Relayer incentivization, a year plus. Yeah.
Okay.
Yeah. I mean, this next year we will spend increasing the number of production implementations of IBC, increasing the robustness of existing production implementations, and adoption and monitoring network usage. That's going to be the primary work on IBC over the next year.
Okay,
I could be also the development of additional application protocols such as cross-chain collateralization. That's really important because this protocol is extremely powerful in general and will allow us to do a lot of things that allow for models like follower chains and much more complex network topologies than currently exist within the blockchain space, all while ensuring interoperability across these chains.
Okay. Another quick question is, in answer to a transaction fee question, it was mentioned that IBC connection wouldn't need to be updated with every packet sent. What is meant by an update and when would they be made?
That's a great question. June, you want to knock that one out?
Sure. Right.
Do you want me to repeat it, June?
No, I read it. So packet is queued inside the state. So once you push the packet, so it is quite opposite from what event in Solidity does. Or transactions. So transactions or events are stored inside the block, but not persist over the state. So unlike them, IBC pushes the packet inside the queue, which is inside the state, which persists over the blocks unless you manually prune them. So if you pushed 3 packets on 800, 801, 802, you can relay the header after 100 seconds, any packet after that. And you can prove every packet sent before that at once. So that is what we need to, when we are saying the update client, when we are saying update client, we are pushing the header into the under chain, and that can be used to prove every packet sent before that.
Yeah, and headers are a moment in time. And if we think about concepts like the unbonding period and the fact that these validator sets can change over time, it's important to continually update these roots of trust or headers within the opposite, with the counterparty chains.
Okay. We've got another question from Chris Goes. I guess he's testing everyone's knowledge, huh?
Keep them coming, Chris. Let's do this.
We could do this all night or day.
Oh, yeah.
Who can develop application protocols? And do you need Tendermint's permission?
That is a great question. This is the wonderful beauty of open source software. All of this code is public. You're more than willing to go, you're more than able to go look at the ICS specifications of what defines an application protocol. Look at the 2 implementations that actually, I think there's 3 implementations currently for application protocols. It's essentially the earliest demo that we did. Another is the current implementation of the token transfer protocol that was contributed to us by the Iris network team. And you can see that in the current demo. And then third, Everett protocol has been working on a cross-chain account protocol that you can also see. So there's beginning to be a number of implementations out there. If you're looking to do so, you don't need any permission from anyone. IBC is a permissionless protocol. We make open source software. We encourage you to go pick it up and give it a try.
Anything to add, June?
Nope.
Okay, so I don't think we have any more questions, but I think just closing it up, maybe well, it was Jack's birthday this weekend during the hackathon, but June, you were there. Was anyone playing around with the IBC demo that you saw, and did you have any things that you noticed, or there were any things that you want to call out?
Yes, so interestingly, there were say more than a few projects that worked with IBC on the hackathon. So unfortunately, I didn't judge them all. So I'm going to say first, sorry if I don't mention you, but every project worked on the hackathon with IBC was great. There was a team named, was working on the multi-DAO, which is utilizing IBC in order to communicate on the substrate chains. So instead of implementing IBC on the Cosmos SDK, what the Tendermint team is currently doing right now, they were using IBC on substrate to communicate on 2 chains, where both were substrate chains. That was interesting. And
I think in June, just to sort of follow on to that particular example, I think that this highlights the flexibility of the IBC protocol, that it can be used on a number of different underlying chains that are not built by us. We have designed this protocol to be generally usable by blockchains all throughout the ecosystem, and not just Tendermint and Cosmos-based chains.
Exactly.
Thanks, June.
So the client semantics, for example, does not rely on the Tendermint specific properties, and something like that. And there was Everett protocol who implemented, so they have proposed the interchain account spec on the ICS repo, and they implemented that on the SDK in this hackathon. And they utilized that to send staking derivatives leverage NFT to another chain.
That is a handful.
That's a lot of things. It does actually look like we have another question that I don't want to neglect from our own Gautier Marin. He's asking, what are the next steps to getting IBC ready for Game of Zones?
Yeah, absolutely. So Gotima, that's a great question. I think at this point we need to spin up some test nets internally, i.e. test creating test nets. We haven't done the demos that we have that all run on a local machine essentially. We haven't done a bunch of these where independent parties are running them. I think we're going to do some refactoring and additions to the code to bring it more in compliance with spec before we begin to do that. But I wish I could give you a more concrete timeline, but I think sometime over the next month, we should start seeing IBC test nets.
Okay. And then I guess I have one last question is based on this demo, right? It's kind of the first way that you can get involved with IBC. There's basically, like, if you are familiar with Cosmos SDK, this is an easy transition for you, right? Is it any heavy lifting or any challenge to do this if you're not familiar with the SDK? I guess kind of like if you're, yeah.
Yeah, I mean, that's a great question. I think when you're learning any software stack, like the Cosmos Tendermint stack, we have written a lot of code all the way down from Tendermint at the base to the SDK, which is the application framework, to IBC, which is the communication framework. Each of those protocols and levels has its own amount of complexity. Now, for me personally, when I'm starting to learn a new stack, I try to pick one piece and learn that first, and then use that foundational knowledge to inform the rest of it. Now, if you are new to Cosmos SDK and new to Tendermint, I think it's easiest to understand Tendermint is a database. The Cosmos SDK is an application framework like Ruby on Rails. And then IBC as a layered communication protocol like TCP/IP. So, or OAuth is another one where there's handshakes and transmission of secure data across channels. There's a lot of examples of those in the wild. So whichever one of those layers you feel most comfortable with, like let's say you're a DBA and you've got a lot of experience with databases, digging into Tendermint first and then building an understanding and confidence from there would probably be best. If you're a networking guy and you understand handshakes very well, starting at the IBC layer might make the most sense. And then you can dig into these underlying primitives around proofs and headers and roots of trust, and start to grow your understanding from there. But this is a huge stack, and some prior understanding of blockchains, distributed systems, databases, layered connection protocols will help you understand this as well. We have really endeavored to make this as understandable as possible. The spec that Joon and Chris worked on is excellent, extremely detailed, and able to be picked up and used to implement in other languages and protocols.
Okay, so we do have one more question. Sorry, from Mayor. Do you see difficulties in synchronizing between chains that advance at different speeds? And his example is Solana at 400 millisecond blocks communicating with Cosmos Hub at 7-second block time.
Yeah, Joon, do you want to answer that? I think that within the protocol, there's the concept of timeouts, i.e. how long a given root of trust is good for and how long you have before the packet times out and you can't receive it anymore. Adjusting the timeouts for the speed of the individual chains is how I think we deal with that in protocol, but I could be wrong.
Exactly. This is an interesting question. We put, as you said, a timeout inside the packet transfer, more specifically. So when the packet is not delivered within some blockade, it will be reverted. So the packet, the side effect of the packet from the origin chain will be reverted manually. And the handshake, the connection and the channel handshake is not affected by the different block synchronization period because they are perfectly working in sequence. So there's no way that the asynchronous communication can affect on the handshake process.
Yeah, in Mayor, that's something that we took care to design around in the creation of the IBC protocol, and remember a lot of conversations about this during the spec development.
Okay, he's building on it, but thank you, Mayor. Will the protocol be backwards compatible? I've heard you guys discussing it before, but for example, if the clients on either side require updates, will both chains need to update in sync, or will an update on chain A force an update on chain B?
I think because the chains are independent actors, I don't think you can force updates on any chain. You know, I think IBC will be backwards compatible within the 1.0 line. If we end up adding a bunch more features like relayer incentivization and do a V2 of the IBC protocol, which I think is something we'd all like to do. But again, I was talking about the caveats there and what we need to see as far as production usage before that would happen. If we do a V2 of the protocol, that would likely not be backwards compatible, but the current plan is to maintain backwards compatibility as well as provide an upgrade versioning and negotiation strategy. And you'll see within the queries and transactions that you're creating, there are version numbers for IBC, and currently the one that it's showing is 1.0. So long story short, we have thought about that. We don't really have a concrete answer for it, but we have embedded data within the protocol that will make it easier for us to automate some parts of this potentially.
I want to add that it is possible to run multiple versions of IBC in the single chain. So connections can live in multiple connections with multiple versions of IBC can live inside a single chain. So even if the backward compatibility breaks, then the different IBC module, different version of IBC module on chain A and different version of IBC modules on chain B can communicate with their own respective compatible versions of others.
Wow.
Yeah.
Really cool.
So version negotiation and versioning is something we've thought deeply about in the creation of this protocol, and it's extremely important, as you note, for a robust protocol of this type.
Okay, so we have another question. Can existing Bitcoin and Ethereum blockchains be integrated to Cosmos?
Yeah, so that's a great question. Now, when we're talking about IBC being a layered connection protocol, if you think about TCP/IP, the bottom layer is like the machine layer, and then you need to have a network layer. In much the same way, the bottom layer of the IBC protocol is the consensus mechanism of the underlying chains. Now, IBC requires instant finality, i.e. once a block has been committed to, it is final, not probabilistic finality like what exists within Bitcoin and Ethereum and other proof of work chains. The way that we are planning to deal with this is to have peg zones that assume the risk, the custodial risk of transferring assets between something where finality is probabilistic, i.e. you need to wait 6 or sometimes more transactions on the Bitcoin or Ethereum blockchain before they can be considered final. And then even then a chain reorg could come in and roll those back. So there needs to be an adapter between the proof of work chains and the proof of stake chains. If you want to see what one of those looks like, we have a project called Peggy, which is getting close to production readiness, that has some details on how that pegging system works. We're working with a couple of different companies as well to peg Bitcoin. That presents a different set of technical challenges because of a lot of the legacy cryptography and system within Bitcoin itself makes it much more difficult to create these types of pegs. But the folks over at Keep Network, the folks over at Suma One, the cross-chain working group, all doing excellent work on this front. And it is something that we plan to do, and we have been putting in significant work towards. Hopefully that answers your question.
Hopefully it does too. And I think that's all the questions we have. So we've been on here for a while, but also if you listen to this later, the team right now is Tendermint, Interchain Foundation, and Agoric, the IBC working group. But if you're interested in getting involved, there are regular ecosystem calls that you can listen into, and we'll probably be back maybe soon with an update on the demo with Jack and June. Does that sound good?
Awesome. That sounds great. Thank you very much, Michelle and June. That was a fun one.
40 minutes went by.
I think that was 50. I think we rocked it.
Good. Thanks, guys. Thank you, everyone.
Thank you very much. And if you guys have questions on IBC, holler at us. Talk soon.